And I would like to introduce a highly qualified entrepreneur in upstate New York, uh, John Hart. He's the president of Lumetrics. He has over 30 years of engineering, business development, and general management experience with experience with Fortune 500 firms such as Bausch& Lomb and Allergan. He also has extensive expertise in startup companies with the development of Lumetrics. Lumetrics has received Series A round of investment by a VC firm in New York State. Lumetrics is now manufacturing the university technology in New York under the name OptiGauge into three primary markets: optics, medical devices, and ophthalmics. And has moved sales beyond its first unit installation into multiple purchases and rollouts into customer factories. Let's give John a big welcome applause. And, thank you for being here. Thank you very much.
So I have put material on the end of each aisle: my presentation, some business cards, and our brochure. And what I'm going to do today is to walk you through what our company manufactures. I'm going to give you a chronological history. We're in our 5th year right now, and what the technology does. And then at the back end of the presentation, I'm going to talk about the license terms and then something about funding, because we've gone through several rounds of funding now. So in the very beginning, before we formed the company, we practiced with some venture capitalists on our pitch. And one of the things we found out very early on was that our product is a hard to understand technology. So if you go to our website, you'll actually see a cartoon that we developed that allowed us to have balloons that come up with words in them and moving arrows that explains our technology to a venture capitalist. But what I do now is we simply say that we send light that you can't see, which is problematic, onto a surface, and we collect reflections from one or multiple surfaces. This technology was developed by Eastman Kodak back in the late 1990s. They developed it to measure film support and gelatin coatings, and then they morphed that into also aligning CCD detectors and cameras and other applications still in use. So the company, in September of 2002, because I've been in the optics field for many years, and we were close to the High Technology of Rochester organization, they had gotten a grant from Joe Morelli, who's an assemblyman in Arundequite, New York, to search out orphan technologies within Kodak and Xerox. The Kodak individual was a retired employee who did the digging for the IP, came to us, myself and my founding partner, Chris Cotton, and said, "What do these patents mean?" Chris looked at the patents. We had a 5-page white paper along with that, and he said, "We're in. We'll take the deal," whatever the deal was going to be. So in September of 2002, we learned about this technology that Kodak was willing to license out. And it was a series of patents, and then it also was an application that was in the patenting process. We then went in search of capital. But before we went in search of capital, High Technology of Rochester had actually gotten a small grant from the state. So we actually got what I call pre-seed funding, $25,000, not a big number, but it allowed us from September of 2002 until December of 2002 to bring on a marketing person and help us finish the business plan. Simultaneously, along with that effort to finish the business plan, we went to our local venture capitalist that I knew from my business contacts, Trillium, and presented to them some of the projects we were working on. They were interested in that. We presented this idea to them, and they said, "We like it a lot." And actually, in December of 2002, gave us a term sheet in the first meeting, which is quite rare. My gut is they were betting on the people, and because Trillium also, Denny DeLeo, used to run, I think, the patenting department at Kodak, they knew the strengths of the IP, they were willing to take a chance at that point. We actually passed on the first offer because we weren't sure yet whether it was as robust a market as we wanted it to be. Went back in January, presented a second time. They said we like it even more, gave us a better term sheet. And in March of 2003, I think we closed in March 18th on the license and March 19th on our funding. So we had seed funding. It was roughly $250,000 that got us, up and running at that point. In our presentation, you'll see that I call it Find the First Money, which is really an important part to get any business going. So we signed in the license at the same time as we got our funding. All through the process, as we were going looking for additional funding, and I'll explain the A rounds that we went to and the individual investor rounds, we were able to, and Kodak was very good at allowing us to come into their operations and to actually show investors over there is where one of the machines are being used, and actually show it in use. So it wasn't something that wasn't solid, something that wasn't being used. It was in use, it was a device, it was proven, and it had patents. As I said, we licensed 6 patents in an application, and the in-use added the legitimacy. Our first year was spent scoping out markets. And by the way, if you have any questions as we go along, please just, jump up and down and get my attention. Good point, see? If you look at our brochure, this is our third iteration. One of the things we've done is we've tried to pictorially show a customer, this is the front page of our website, how the system works or what it can be used for. And basically, we send a beam of light out through 2 simple optics. Every time it hits a surface with a reflection on it, it bounces a reflection back up through the optics into the interferometer. And it's used to measure thicknesses of materials. So you'll see that we have, this is a balloon, a medical balloon. We're actually measuring the coatings on a medical balloon, the thickness of a medical balloon. One of the problems when you make a medical balloon is you start off with a tube, you put it inside of a mold, you heat the material up, and you expand it into the balloon shape. But when you expand it, you have weak areas on the cone angle, which is not a good thing, because if they stick it in your body, inflate it with saline, and it breaks along its long axis, it's okay. It's not great. If it breaks circumferentially, you have a problem. So we're selling a lot to that, where we actually can measure the thicknesses and the distances of that material. We do some work with wafers, because at our wavelength at 1310 nanometer infrared, silicon is transparent. So we can see through a wafer like you and I can see visible light through a window. Ampules, kind of a weird application, but in heavy use in the medical industry. They need to know when they flame over the top of an ampule how thick it is. If it's too thick, they can't open the ampule without damaging the material. If it's too thin, it breaks. In this particular case, it was body adhesive. So we have multiple applications. We show it visually. It measures thickness of materials. Although now we've actually gone to applications where we can do surface measurement, characterization of surfaces. There's the technology can also be used for pressure sensing, temperature sensing, although we're not in those markets.
So what was the standard way of doing this? What was the standard way of doing these precise measurements?
Very good question. One of our customers is Abbott. We can use their name. And on TV, you see blood glucose monitors that are advertised all the time with little test strips that go into the monitor. You prick your arm with a drop of blood, touch the test strip to the blood, and it gives you a blood glucose reading. Those little test strips start off as 1,000-foot long rolls, 5 layers thick. You have 2 outside liner layers, which are just material, hard polymer film, 2 layers of adhesive, and then a barrier layer in the middle. So we sold to Abbott, and Abbott takes a sample from the front and the back of this roll and checks to make sure all 5 layers are properly made for incoming QC. We then went to Abbott's manufacturer that makes this roll with 3 feet wide, 1,000 feet long, and they apply these 2 layers of adhesive. Now, it's kind of tough to get a precise measurement on a liquid layer of adhesive. In fact, it's impossible. There is no technology that can do that. Further, we do that when they're making it. So they make this roll, It goes 40 feet a minute, so it takes several hours to make a roll of material. But we're actually measuring the adhesive when it's still liquid in the front of the curing oven, the back of the curing oven, and after it goes through pinch rollers. So they can't do it. I mean, their idea of a new technology was a digital Sony drop gauge rather than a mechanical drop gauge. But you can't measure adhesive that way. Another good example is the contact lens. Very competitive industry. We can measure center thickness, and we now have some optical ways of actually measuring power online as it's being made. So CT, center thickness, is very, very critical, and it tells you whether a lens is a good lens or a bad lens. That was, again, a touch gauge, but it's a soft material, so its accuracy is not very good. So first year, as I said, we actually identified 11 vertical markets. We're focused on 3 of them, and interesting enough, those are the 3 markets we're still focused on 5 years later. We redesigned the system for industrial use because the Kodak system was a very good system, but it was really designed as a lab system with a lot of adjustability because it had to be used for many, many different applications. So we redesigned it to be online data collection, so immediate feedback, and software-driven rather than hardware adjustable. And one of the mistakes we made, and I tell people in all my discussions, is that we grossly underestimated the time that it would take to take a lab unit and really get it into an industrial configuration. It took us over 6 months to do that, but we survived. Our second year, some of the keys, first thing we had to do was find our first customer. And fortunately in Rochester, there's a lot of companies that are in optics and in metrology. One company, Corning Tropel, has allowed us to use their name. The senior metrologist, Vivek Badami, who's now at Zygo, which is another big measurement company, said, I'm interested in what you guys are doing. They bought the first system. And the second thing they did for us is they helped us write papers, because one of the obstacles we found in the very beginning of our marketing effort was trust us. This is what we're telling customers. You can't see this beam of light, but it's measuring this material and we know it's accurate because it has an inside clocking laser that's very accurate. Well, that's a hard sell. So Vivek and our CTO, Todd Blaylock, did a paper. Spent about 6 months developing a new NIST traceable gauging system, which is really measuring air. Air has a known index. They presented it at SPIE in 2005. It's now on our website. And now when anybody in the QC departments or the R&D departments ask, how do I know what you're building is accurate? We point to the paper, they read it, and they understand. So that first customer helped us in a lot of different ways. We continued the system development. And our second big mistake, not fatal, but big, was, and we learned this kind of anecdotally. We'd have customers call us. They would talk about the system, what we could do, and all the features and benefits. What we didn't do was to qualify them that they were in the right price category for our system. So I remember taking a call from the Abbott person, a woman quality engineer, and she asked if we could measure this 5-layer film. I said, sure. She asked how much it was, and I said, 60 grand, and she said, oh, is that all? And then I knew we were in the right market. Other customers would call and say, well, I don't want to spend more than $10,000, and you knew early on that they weren't in the market that you wanted to serve. So we now never finish the first conversation with a new customer without having them ask us or we tell them. Because as we've since learned, we've gone through some sales training now. Miller Hyman, we just finished that up a couple months ago. And one of the things they teach you is you want to lose fast. So if you're not going to get a sale, you want to know it right up front. The faster you lose it, the better off you're going to be. You identify your ideal customer, and you lose fast on the non-ideal customers.
John, I have a question. So you were looking for a few markets to enter into. What was Kodak doing with it? What was their intention for this technology? Did they already have a market sort of planned out when they started to patent this?
In the license term, you'll see kind of an unusual twist that we put into the original license. And it was put in there because, and in fact, the person in the audience here, Mr. David Brach, was the licensing officer at Kodak that helped us pull the technology out of Kodak successfully. And one of the things that Dave knows about and I knew about that Kodak freely offered was another large company was interested in the technology, I'd say like 1998, 1999. Kodak tried to go through this other very large company and sell the product, but it's probably like a wine before its time. You know, it wasn't quite developed for the marketplace. But Kodak was using it all over the place. In fact, Mike Marcus, who's the inventor, the scientist, who's still there in their R&D department, who's a very prolific patent writer, and is our kind of unofficial godfather of the company. Mike, I've lost my train of thought. Lost my train of thought. What's that? Right. So Mike would be wearing a beeper. This is a guy that's a PhD, very smart guy. But Kodak had these systems all around their operation. They had them in film. They had them in a area where they were qualifying their film emulsion application tooling. They had them in what was called optomechatronics, which is over on the west side of Rochester, where they were putting CCDs into camera bodies. So Kodak had it throughout their organization, but I think, this is my gut feel, my opinion, that they didn't market the product because they tried to go through this other outside company that really never sold. So they decided to use it internally, but allow somebody to take the IP out. That was the point.
Okay. So thank you. So John, Kodak reserved the right to continue to practice the technology in-house?
Yep.
And you have all fields of use, no restrictions in terms of fields of use?
The only restriction we've got is we can't sell it to competing companies with Kodak, basically like Sony cameras, that kind of thing. We only have a non-exclusive. So I'll talk about the license since you asked the question. When Dave and I first met, one of my questions was, how can we get a license out of Kodak? Give me kind of a gut feel for time frames. I said, what would a non-exclusive take? And he gave me roughly the number of months. What would an exclusive take? And it was a much more difficult and more costly venture for an exclusive license. And Kodak may not have been willing to do it at the time. So I went back to my investors and ourselves, who were going to put our heart and soul into the business, and said, what do we need as a minimum to know that we have some protection? Especially because this other company had tried to enter the market a couple years before. So we came up with a license structure that allowed us to have a window of time that if we saw somebody else come in and try to license it and jump over the top of us, we could pay a chunk of money and have a 2-year exclusive. So it was easy for Kodak to get it approved, easier. Our venture capitalists and ourselves were more comfortable because we had a jump start. Basically, that's what you were buying. As much as 4 years, but in reality, we didn't even need to trigger that option. But it protected ourselves. So we could put all our money and effort into the business and still have a protected business. Since then, we put a lot into IP work. In fact, I was just looking at it the other day, between royalties and just patenting and fending off people trying to steal our patents, we spent about $80,000 this year. So of that $80,000, about $34,000 is capitalizable, meaning it goes onto a balance sheet, which means it's actually the cost of the filings and the arguments to get patents that you can put on a balance sheet rather than straight expense. So. Third year was a big year for us because we got our first funding. And there's an organization in the state called New York State Small Business Technology Investment Fund. In the early 1980s. Oh, okay. Okay. Are you with it?
I'm Clay. Talking phone.
Oh, Clayton. Oh, how you doing? He's on my board. I never met you. Oh, nice to meet you. Oh, funny. I knew Tony, and then I met Sonny, right. Right, okay. Actually, NYS BTIF came in, and we did the full pitch, the presentation, the business plan. It was, I think, December 20th in '04. And Tony and Jeff Weatherby, who were your predecessors there, said, we like the deal. And they came in and they said, we'll give you a term sheet. And we had a term sheet in about 2 weeks, literally. It was a 3-to-1 match, so we had to go out and find $3 for every $1 that they would kick in the fourth dollar. But it gave you your first term sheet, which is a big deal, because it gave you a valuation and some of the terms of the structure of the deal.
Is the 3-to-1 match cash or in kind?
Cash, yeah.
And that's more flexible.
What is it?
Flexible, like 1-to-1 flexible?
Not that quite that flexible. Flexible like we'll talk about.
Like 2-to-1? Okay. So now, I don't know all the history of New York State Small Business Technology Investment Fund, but my understanding, and I went down to New York and I pitched the company to the committee, was that in the 80s you got money from the state, made some investments, and several of those investments have paid off and give you some liquidity to do further investments. Okay. But the big deal is, and this is not just sucking up to you, believe me, is that we get a term sheet, and that's a really big deal. And it took us from December of '04 to November of '05 to actually close the A round. And it took that long because in early '05 we attracted a Capco, Stonehenge Capital in New York City. They have, part of their mission is economic development in, I call it impoverished areas of New York State, but it's like challenged areas, anything outside of New York or Westchester County. They came in as part of the deal, as part of the syndicate. And then we had local interest from the Rochester Angel Network, which was high net worth individuals, a loose affiliation of angels, people that own banks, for example, and people that were in these presentations here today. A couple of them are actually angels in the Rochester Angel Network. And they came into the deal as well. Stonehenge led it. The state followed. The state only required an I Love New York clause is what I call it, meaning you can't split with their money without their approval. Although I think from what, or without paying, right. Yep. But I think one of your big returns was actually a company that was acquired and then moved out to California, yep. And then we put the deal together, and we closed in November of '05 on our A round. In between, and I skipped a big step here, we had our seed. And of course, we weren't generating much revenue, so we went out with 2 angel rounds of investment where we offered convertible debentures, which is basically you loan the company money, we'll give you an interest rate on top of that money, and when there's an A-round event, if there is an A-round event, you'll get an advantage on that money, a discount, and you convert to preferred stock. So we did 2 rounds of that at roughly the same price, and then when we did the A-round conversion, everything converted to a preferred at the price that they bought into at the time. So now we have, it takes us into 2006. We use that A-round money for accelerating sales. We're now starting to hit some of our key markets, ophthalmics, medical devices, precision optics. Still trying to stay within our 3 primary markets, but of course, being a young, hungry company, you're opportunistic. If somebody comes in and says, I'll buy a machine, you know, it's hard to turn down a $70,000 or $80,000 sale, especially when you're always cash constrained. We're actually getting to a point now where we're starting to push people away outside of our primary market because we get defocused in our engineering and development area. And it's happening more and more internationally where we're dealing with large, like I'm going to Japan next week to talk to one of these customers who we may say, you know, we can't do what you want. So let's, you know, part friends and talk in a couple of years from now because it just defocuses you from your primary market. Use the funds to staff up engineering for product development. You can see we're now on our 3rd generation of written material, but the real key to our business now is if you look at if you were to Google catheter measurement, will either be 1, 2, or 3 organically, and will definitely be 1 or 2 in the sponsored ad sides on Google web pages and all the different browser pages, which is where everything comes from now, pretty much, unless it's repeat business. I had a guy, Eric, and I can't remember his last name, call from NUI Galway, which is the National University of Ireland in Galway. And he says, you know, I just Googled catheter measurement, and I saw you come up. Can you guys measure catheters? I said, yeah, we do it all the time. And I said, in fact, we have a rep, a very good European rep, lives in Galway, has an office in Galway. I said, Eric, do you know Dan Tracy? He goes, oh, yeah, he's my friend. I'm going, okay. So I emailed Dan, and Dan was over there a couple hours later. So he found us totally the roundabout way. I mean, it's an interesting lesson, and through the web.
Sorry.
That's okay.
So I'm not sure how much of an issue this is, but the fact that, you know, SBTI has this sort of I don't know, clause in there that says you got to stay or you have to give back money. So does Capco. Capco has a
It's not give it back,
there's a penalty.
It's a penalty.
It's a penalty provision. And Capco, in fact, the Capco themselves are under obligations to try to keep the company in New York State. Otherwise, the tax credits that they get recaptured by the state. So now, do you know, I'm not sure if there are other companies who are in your situation where you're getting SBTIF and Capco, but do you think that could be a hindrance moving forward in attracting outside VC money, that there is such a sort of term and clause in the agreements?
With us, I don't think so, because we got the people in Rochester to build a product. It's a high-value product. You're not going to make $100,000 a year. We get a lot of our content is local, and we can get it easily. So we're not going to be in a position that I can imagine in the next few years where somebody's going to say, go to China, go to Taiwan. Yeah. I knew that Boston situation very well. Les Fritzmeyer was the guy. Wakanda is his company. He's a friend of mine. He came very close to staying in Rochester. But Massachusetts, like their Green Fund, much like the New York State Fund, came in and said, we'll put the first money in, and that led the round. So that had the Massachusetts hook. He was also from Massachusetts, so that didn't hurt. He's a Red Sox fan. So that was, and that's one we all feel kind of bad about because we lost it. You know, Duncan Moore talked about it this morning, and we were begging him to stay because we liked the guy, but we also liked his business. But so later in 2006, we did I call it the A+ round, basically another round. State came in, and the way the deal was structured, you have to go back to all the preferred investors. So it becomes kind of convoluted on how you go to investors, get their approval. But the state came back with a follow-on. Stonehenge Capital came back with a follow-on. And then another Capco showed up, Whitecap, that actually called Stonehenge and said, I want to do a deal, and I have to do it in the next 30 days. And I don't want to do any due diligence. And I'll take the same terms you get. I'm thinking, okay, this is pretty weird. Yeah. They have a DBA in New York, but they're from Texas. Yeah. And I send all the packages to Clayton and to Sonny and to Brian Modell at Stonehenge, and I send one down to Peter Huff at Whitecap in Texas. He's never on the board calls. He never asked questions. They had money they had to meet their insurance hurdles. So we closed the deal in 30 days, which is nice because it gave us more working capital, which we still have, and it got us through the end of last year. Currently, we're in our 5th year of operation, not 5th full year. Our goal at the end of this quarter is to hit our first 7-digit sales number this quarter, which is a big deal. We don't release numbers, but you can figure out what that is. We'll be profitable this year if we hit that number, which is a real big goal for us, especially in this current economy. We're investing, as I talked about earlier, very heavy in intellectual property. We've got a patent that was issued on web film measurement, which is good because we sell into the web film market, and we can go to customers, you know, big plastics co-extrusion machine companies or manufacturers of film and say, we got a technology that works, and oh, by the way, here's a patent. and you show it to them and they go, "Ooh, that's pretty cool." Well, it protects them. So not that they worry too much about that, but it's still something that shows we're serious about their marketplace. We did a deal. We have a development contract with a very large optical company working on an OEM application for them. We use a patent firm that's not in Rochester or Western New York. We use Reed Smith out of Philadelphia. And the guy's name is Bill McNichol, and he's very good, but he's terribly expensive, $625 an hour. And every time I get him on the phone, I say, "Bill, talk fast." He says to me, "John," he says, "I will, but remember for you, I discount to $585 an hour." So it costs us about $600 an hour for this individual. But in the 2 patents we've gotten allowed so far, we've done, every claim has been allowed first time through. So either he's very good, or maybe we're not asking enough out of the patent office. He helped us in a defense where a customer, a very large optical company, basically took our material and claimed ownership of measurement of a contact lens, center thickness, and filed a patent. We saw it when it was published before there was any office action on it. We looked at it, and basically what happened was the other contact lens companies got all freaked out because we were doing business with them, and they said, "Hey, this other company's patenting," they're saying they invented center thickness measurement using the Lumetrix OptiGauge. They even had our address in there of Henrietta, New York. They even had our CTO's drawings in the patent application. So what I've learned in that particular industry is they shoot first and they ask questions later. So we spent about 14 grand by the time we were done writing up a 140-page response to them saying you can't patent somebody else's work. It's against patent law. You're stealing. So they've since taken all the claims out that were not their claims. But it froze part of that market for a while. But we had a good patent attorney. He knew what he was doing, put this together. It's probably the best 14 grand we spent in a long time.
How long was that process? Like you sent them the first letter and then they responded with, "Okay, we'll change our claims."
What we did was, what Bill said to us is a bunch of ways to go. You could file for invalidity and go that route. He said another way to do it is he called it the stink bomb. He said what you can do is just send this big package right down to the USPTO and have them put it in the file wrapper. So if somebody's looking through the file wrapper, which is the file history, I guess, Ted, that goes back to the days we used to wrap it up in brown paper. They call it file wrapper. They're going to see this 130-page report saying you ripped us off. So that's going to make it tough for them either to get a patent or if anybody wanted to license it from them. It's kind of a poison pill. The time frame was probably, we first found out about it to when we had the response. It was less than a month. And then we took that response and sanitized it for our other customers and then did a series of conference calls with them explaining what had happened. And every one of them has come back, including the company that was trying to rip us off, and are buying lots of equipment now because they realize now that there's no validity to that patent application. They don't have to worry about it. And we've, I guess, unofficially declared our rights to that kind of measurement.
Well, that's a great lesson, like in making sure that you do sort of intelligence, sort of, look at who's filing these things, because once it's issued, it's a lot tougher to make it valid.
Yep. Yep. And we had non-disclosures, and we had tons of meetings with these folks, and they were buying product from us, and we were actually helping them out with, probe design and other kind of things, and they turned around and, yeah. So we have some more quotes we're putting out to them. I was telling David earlier that the price of those development projects have just gone up to that particular customer. Until my finance director recaptures that 14 grand, then she'll be happy. So we've also gone through a strategic plan update. We're now on our second version of that. We do that, and I lived through the Bausch and Lomb days where a strategic plan was like having your fingernails torn out of your hands, your fingers, because it was just an awful process. But we brought somebody in 2 years ago to help us through a simplified strat plan process, which is really to think, organization, what your markets are, really high-level stuff. And we spend the time every year to go through typically about 3 one-hour sessions just to update everything. Our strengths and our weaknesses. That's one of the ones that popped out the other day was A year ago, we said, our intercommunication between departments in the company was a strength. Now, one of our founders is saying, no, that's our absolute weakness, which we're going, whoa, that's a big change in 1 year. And that's because we grew from 8 or 9 people to close to 20. So we see now that we have siloing in our own organization. So as a management team, what are we going to do about that? So that's the kind of thing that we find in the strategic plan, which is good. So we've done a couple updates there. Our sales approach, we had independent reps in the US, we had independent reps in Asia and Europe. Right now, we have one group in Japan that appears to be doing a good job for us. We canned 2 of the 3 reps in Europe. 2 of them just didn't, we can't figure out why. They seem to be in our market segment, selling product, nothing was competing, they just did not perform. The 3rd rep is the one I was telling you about, Dan Tracy, who knows everybody in Ireland. And he goes there and he knows how to market, how to sell product. In the US, as we go out and do surveys, we hired a marketing group to help us brand our product. They went out and talked to all our customers, and the customers said, we don't want to deal with a salesperson. We want to deal with a CTO or an application engineer or somebody in your organization. So we're going to morph our domestic sales into everything direct out of the factory. We do it now where we go out and somebody buys a system. We had an order in from a big company, and it was $70,000 basic system. It's $6,300 for maintenance and service per year. It's $2,500 to install and train. So we send somebody out, they install and train that application engineer. That engineer now also has been trained in selling. They went through the Miller-Hyman sales training program. So they're in their training, but they got their ear to other applications. In fact, one of them went down to Florida last week and came back with a possible sale. So our 3 primary markets, and we're getting multiple repeat customers, which is great. We have a new one that's emerging. We knew about this from the very first day that we did got the assessment from Kodak and High Technology of Rochester, and that is that there's beta gauges. And they're beta particle emitters and collectors. They go across the web. There's 30,000 of them in the world. They're all over the place. They're also powderized nuclear material. There's spills. Some countries don't allow it in. State regulatory agencies are starting to clamp down big time. The feds are not clamping down yet because they've got other chemical is still rated before the low-risk radioactive stuff. But now we have 3 or 4 companies talking to us about exclusive deals in their market segment to measure the top of blown towers where they make bag material, to measure on flat webs, getting rid of the beta gauge and put our opti gauge in place. So that's a nice market that would probably be an OEM device. And we're also doing with ISO compliant. And I say compliant, it's different than certified. It's a lot cheaper. You don't have to have somebody come in once a year, do an audit. You don't need to have that for a medical device typically. If you're going to sell it yourself, you do, but if you're selling it to somebody that packages it and sells it down the road to somebody else or to the doctor, compliance or quality system is what you need. In fact, we had a customer that spent 2 people in our shop for 3 months helping us do 5S and lean and help us finish off ISO 9001 with the medical device standard attached to it, which was very nice. I talked a little bit about license terms. It was a 3 to 4 month process. It would have probably been faster, except that I had to make sure I was bringing along the finance people at the same time that we were actually on contract negotiations. And I wouldn't say Kodak was a pushover, but it was pretty straightforward. I mean, it's like Rick said it this morning, Rick Richmond with U of R. If you go in there, you know what you want to license, you find an internal champion, and don't ask for the moon, you've got a real good chance of, I think, doing something. And be a little creative, maybe on what we had, which was the exclusive right to try to block somebody from coming over the top of us and give us a head start in the market. Our funding terms. This is not the reason for this seminar, but some of the things that we learned. Our pre-seed funding, which we got from High Tech of Rochester, was a very, very good thing. Gives us your first little bit of money, adds a little bit of legitimacy, helps you polish up your business plan, and gives some good market survey data. When we went to the seed funding round, in this case was Trillium, typically I'm finding that seed funders don't want to value a company. They don't want to pay too much or pay too little. So what they do is they say, okay, we'll give you, in this case, $250,000, but we want a 70% discount to the A round, which means that when the next investor, when Clayton comes in and pays $1 a share, they want to pay 30 cents a share. Clayton's not going to be happy about that because he's paying $1 and the people that came in before him are only paying 30 cents to convert. That doesn't seem very fair. So that's exactly what happens. You get into a trap that you have preferred shares coming in the A rounds, and you have earlier investors want discounts to those A rounds. I call it the double dip, but basically they get the use of their money 2 times, plus it makes it kind of tough to negotiate. Now, every seed investor and every A round investor knows there's no way 70% is going to ever fly. So in this particular case, the seed people were crammed down to about, it's around 30% discount, which is much more reasonable. But you're always in this negotiation phase, and it gets kind of sloppy. So if I had to do it again, I would probably just do a private placement. There's several companies in HTR that have done those. They keep all the stock as common. You have to justify the valuation you put on the company, but you can sell it in your earlier phases as a private placement and get further down the road so that when you have to bring in institutional investors, you have a much more developed story. You don't have a convoluted capital structure. It's all pretty straightforward. And then you can probably get better terms. So some of my lessons, you heard this from Rick as well. We were lucky because we had myself, who had some business experience in the very beginning. Steve Heverin-Smith was a marketing and sales VP who's still with the company and a founder. And he was a person that we were able to bring in with that early pre-seed money. Todd Blaylock as our CTO. He was actually working for the 4th founder, Chris Cotton, who's not an active member of the company except on the board. And he was actually doing moonlighting work on some of the early development of the company. So we actually went with a management team that had the business, marketing, and technical expertise, which is not very usual from what I can tell. We talked to a lot of people coming out of Kodak, for example, that are scientists, and Dave Hessler talked a little bit about it, trying to team them up with a business person that they can trust and that has experience. Then you go and start looking for your first round of money. And again, it's always, X times longer, X times more expensive, X times less profit. I mean, it's just, I said everybody knows this except maybe the entrepreneur, which is true. I'm thinking, geez, we can sell 1 million of these things in a year. And Brian Modell probably has a book of, he probably goes, after I say this to him 5 or 10 times, he goes back and writes it in his diary. He's going to show it to me when they exit out successfully, how many times I told him that. And dilution, because we put a lot of sweat equity in the business and some cash, but we didn't self-fund. So we knew, because we were going to go down the venture investor route, that the day you start the company is the day you start diluting. If you don't want to dilute, which is okay, you got to fund it yourself until you get to a point where you've got something of more value. That's our story.
And you do all your engineering in-house and manufacturing also in-house, or you outsource some of that?
I skipped that whole part, what we have in the company today. We do it all inside. We build a box. It's roughly the size of a desktop PC. It's a low coherence interferometer. Inside of it are 3 custom-made boards, electronic boards that we developed with a local company and have made for us. A couple power supplies, and we have the secret sauce, which is, on one of those boards, part of the Kodak secret sauce is a co-propagated telecom laser, which at first we bought for $600, a little 14-pin butterfly devices, very small. We now buy them off of eBay for $59. Yeah. And the reason is, and it's a technical answer, is that we don't have to buy them at a specific wavelength because we can put in a calibration factor, because we calibrate from that earlier study I was telling you about, and use any wavelength we want that's even close. So we just tune it to the calibration standard. We bought every one we could buy. We bought about 100 of them. So we have in-house now, we've got a finance department, 2 full-time people, or I'm sorry, a full-time and a part-time person. We have software development because we've converted all our early code to .NET, which is the latest platform. Our customers, through all our surveys and their requests, they want a complete solution. They don't want to buy a box with a probe and read something. They want something that, like we did an application for Oscar Mayer, Kraft Foods, not our primary market. We did a lot of guerrilla marketing early on by putting product notices in magazines, which you can get for free. So you get nice splashy color things. So we did a Quality Digest about 4 years ago. A guy that was a retired farmer and was working at the Kraft hot dog factory in Madison, Wisconsin, saw this article, called us up and said, can you measure the packaging material they use to package Oscar Mayer hot dogs? And of course, we never say no. So Steve packed a unit up, flew out there, and there's a picture of him with Vern. Steve was a former farmer. He grew up on a farm with literally angle iron with baling wire and weights hanging off of it with our probe on the end. They put the weights in the baling wire because they had an oscillation and they wanted to change the frequency of it. And they measured the packaging material. Now, Oscar Mayer has a 3-layer top and bottom web. Hot dogs come in from the side. They do millions of these things a week. And the top and bottom web are 3 layers. And the middle layer on the top web and the bottom web is $7 a pound for the polymer, which is very expensive. And it's specially formulated for them because when the hot dog is in the freezer case, the lights can cause the fake pink to turn gray. So you're not going to buy a gray hot dog. So they spend all this money on this packaging. This one plant is $5 million a year for this middle layer of polymer. So we are now doing a complete closed loop system. We're measuring and controlling on 4 different lines using an optical switch and an optigauge. They're die controls to optimize that layer so it's the right thickness, because they were putting 20% extra on to make sure it was thick enough. So we developed software. We have an R&D function where we have a Skunk Works lab. We actually developed a product for a customer, which is a hybrid of our current product, to measure the axial length of the eye. So we send a beam of light into the eye. We pick up the cornea, the lens, the retina, and we calculate the distances. And that's going into an OEM production next year. We have marketing and sales. We have application engineering. We are beefing up our software because it's really tough to find good .NET programmers that not web-based .NET, but machine-based .NET. But we are finding people. So we do it all ourselves. Plus, we vertically integrated in one of our key components, which is we use what's called a piezo stretcher. So if you took a 2-inch diameter cylinder with a thin wall made out of piezo ceramic, it looks like aluminum. It's coated with metal on the outside. We wrap fiber 21 meters around each of these discs, controlled tension, and bond it with a UV adhesive. And then we put high voltage on the piezo, and we actually stretch the fiber, the glass in the fiber, on one of these cylinders with 21 meters stretches 10 millimeters. So what that does is it allows us to scan in and out of the material very quickly. So we can now take 400 to 500 readings per second as a web is going by using these piezo stretchers. We were buying them from a local company who developed them, about $2,500 for the stretchers, $2,000 for the power supply. We are now down to about $300 for the stretchers, and the power supplies are made in our building with a company just down the hallway for about $600. So we cut our cost into about a quarter. And we control it. And we just got an SBIR phase 1 to do fiber stretching through NSF, and they just told us we're probably going to get the phase 2 to commercialize it. So we're actually using government money to NSF SBIRs to do our development work for high-speed, ultra-low noise fiber stretching for reticle applications. Any other questions?